Hello and welcome to today's lecture on traffic incident algorithms. Over the last couple of lectures, we've been able to look into the traffic incident itself, also into traffic incident management. We have also been able to look at every aspect under traffic incident management and all the possible high tiers that are used in traffic incident management. So today we're going to be looking into traffic incident algorithms. Now, when there is an incident, minimizing the response time is crucial in every aspect. The most important is the treatment of injuries. The faster treatment arrives, the greater the survival rate of serious injuries during an incident or an accident. Secondly, clearing the incident quickly minimizes the traffic flow disruption and the potential for secondary incidents. That is, the faster we can get the incident cleared off on the road, the better for any form of secondary incident or secondary accident occurring on the road. The actual accident or the actual incident is the primary incident. So any other incident that arising from the primary incident is what we call the secondary incident. Now there is something we call the automatic incident detection, and this has been considered a method for quickly detecting potential incidents. The technology has been in research, development, and testing stages since the 1970s, and during the time, many incident detection methods and algorithms have been developed. Past experience has also shown that when a traditional automatic incident detection system is installed, the number of false alarms has become such a problem that made this algorithm ineffective and not useful, and traffic operations centers stopped using them altogether. Now, what I'm trying to explain here is where it is still a work in progress when it comes to some of these automatic incident detections using some algorithms, because when an incident happens on the road, most of these technologies that have been developed over the last couple of years or in the last couple of decades have been able, because there are some times where they are able to pick what we call a false alarm. False alarm in sense of giving a sign that there is an incident on the road when there wasn't actually an incident, or probably when there is an incident on the road, but the technology didn't pick that particular incident. So we're still going to be looking into the area of the potential false alarms and every other measures later on in this lecture. The human-based incident detection methods, which includes maybe phone calls, passing motorists, and first responders patrols, have a poor enough detection rate that operators are unable to rely on this system as their primary method of incident detection. And that makes it very important to develop a new detection technology and new effective detection algorithms. This new detection algorithm should suit all accident types and situations in sense of car crash, fire, accident on the first lane or is it on the second lane, accident near the ramp or secondary accident, car crash between bus and trucks, bus and cars, etc. So it is quite important that whatever technology that will be developed has to be able to spot incident on the road, and not just about spotting the incident, being able to spot where it happens and the type of incident that happened on the road. And that is the reason why there is a need to develop algorithms and technologies that helps with this detection. And the human-based incident detection method cannot be as effective as that of technology, because there are some times whereby there might be a false a false detection or false call from humans about an incident on the road, and sometimes not everyone can be patriotic enough to put calls through at the times where an incident happens, and also the timing of responding or reporting this incident might not be as efficient as having some of these technologies in place to be able to perform this function. When it comes to traffic incident detection, various methodologies can be employed, each with its own strength and application context. So we are going to be looking at the overview of four specific categories of methods that can be used in traffic incident algorithms. And there we are going to, so The traffic incident detection algorithms are essential for quickly identifying and responding to situations that disrupt the normal traffic flow. So this is a picture. This is a picture of how the algorithm or the technology works in detecting any form of abnormality or anything that disrupts the normal flow of traffic. But this time around, it's going to be in a technology form. So these are pictures showing how the algorithm or the technology works. So these are the various approaches for incident detection. The first one is what we call the sample-based method, which is also called a comparative algorithm. This method involves it collects data samples from traffic conditions and comparing them against established patterns or thresholds to detect incidents. Traffic data is sampled at specific intervals using sensors or monitoring device. Then after when this traffic data has been sampled at specific intervals using these sensors or monitoring device, the sample data is then compared to historical data or predefined traffic models to identify abnormalities indicating a potential incident on the road. Now, this algorithm and approach utilizes comparative algorithms such as the nearest neighbor or clustering techniques to assess similarities to normal patterns. The method generally uses the capacity and occupancy data taken by induction detectors. In this algorithm, threshold that has normal flow conditions. And what are these thresholds? We're talking about the speed, the traffic volume, and the occupancy. This is determined in advance, and the rest of the values are identified as one of the normals. Determining the threshold is hard and it takes a lot of time because if speed, traffic volume, and occupancy is greater than or less than the threshold value, then that means there is an accident. All this is based on the sample-based method, that is the comparative algorithm approach towards an incident management. And there are a lot of examples under this particular method or algorithm. We have what we call the California algorithm, TSC2, we have California algorithm TSC7, California algorithm TSC8, we have the Patriot algorithm, all-purpose incident detection, rapid algorithm. So that is under this sample-based method, there are other examples of it under this particular method. So one thing to note about the sample-based method is that after when that has been established, the speed, the threshold, that is the speed, the traffic volume, and the occupancy, at any point in the system or in the technology, that is, it is greater than or less than the threshold value that has been established, then it will indicate that an accident has happened or an accident has occurred on the road. So that is on the sample-based method. So the second approach for incident detection is what we call the catastrophe theory-based method. In this method, this theory studies systems where small changes can lead to a sudden or dramatic changes in state. This theory can help model and understand traffic dynamics and traffic occurrence. That is, traffic flow can be modeled using equations that represent the interactions between traffic variables. Now, these incidents are identified when certain threshold of traffic density, speed, or traffic rate, in which I explained earlier under the sample-based method, are breached, indicating a potential catastrophic change in traffic behavior. That is, for this method, there has to be a catastrophic change in traffic behavior before we can actually say that an incident has occurred on the road for that of the traffic theory. And the theory itself takes its name from a sudden discrete changes that occurs in one variable of interest, while other related variables are exhibiting smooth and continuous change. We know the variables are speed, flow, and occupancy. Now, when speed drops dramatically without a corresponding increase in occupancy and flow, the alarm sounds. So that is where I said when there is a catastrophic change in one of the three variables, we know the speed, the flow, and the occupancy. So when there is a dramatic increase in, maybe let's say, in speed, or probably when speed drops dramatically without any corresponding increase in maybe occupancy and flow, that is when the alarm goes off that there is an incident on the road. Now, in this, catastrophic theory-based algorithms are able to differentiate between incident and recurring congestion. So the only difference between catastrophic-based and the pattern-based, which is the first, is that the pattern-based method rely on individual variables and preset thresholds, while the catastrophic method uses multiple variables and compares them to previous trends in data for recurring congestion. So that is the difference between the catastrophic theory-based method and the sample-based method. The third approach for incident detection is what we call the statistical methods. Without saying so much, we know when we hear the word statistical, it's going to be mathematical in nature. So that is this method uses mathematical techniques to analyze the traffic data and identifying patterns that indicate an incident. From this, it shows that there is going to be a form of historical data collection and analysis, that is, collection of traffic data to establish a normal operating condition. So when that has been collected, the historical traffic data has been collected to establish a normal operation threshold. Then we now set a statistical threshold, maybe in form of mean and standard deviation for traffic variables like speed and volume to detect anomalies. So some of the techniques that are used are maybe HARIMA or exponential smoothing can be employed for forecast expected traffic conditions and identifying any form of deviation. Now, the statistical method generally this enables real-time data to compare the statistical estimated or predicted data. Any unexpected changes in traffic compared to the forecasted traffic flow are then classified as an incident. Now, under the statistical method, we know there are some statistical tools such as that are used in this. And some of the algorithms that are used is maybe the high occupancy method. We have the standard normal deviation SND algorithm. We have the variation based method, which is quite common when it comes to incident detection. We have the filtration method. We have the stochastic methods. We have the double exponential smoothing method. They call it the DES method. So these are some of the examples of the algorithms that are used under the statistical method. So we move to the fourth method, and that is artificial intelligence based method. And this AI-based method leverages machine learning and deep learning algorithms to analyze traffic data and detect incidents automatically. And I think this is one of the widely used method in the 21st century. Algorithms like maybe decision trees, random forests, neural networks are trained on labeled data sets, and this is to recognize patterns associated with incidents. Techniques such as clustering can also identify anomalous traffic patterns without relabeled data. And for the deep learning, convolutional neural networks and recurrent neural networks are applied to process complex data, such as video feeds and time series data. For under this field, it is usually said that the artificial intelligence based method is the most recent development of the AID algorithms, because these algorithms detect incidents by either a rule-based algorithm or an algorithm that has learned to recognize incident patterns. And some of the examples in which I've already mentioned earlier, such as the neural networks, the ANN artificial neural network, we have the PNN probabilistic neural network, the fuzzy set logics, the fuzzy adaptive resonance theory, fuzzy predictive ART. So these are some of the examples under the artificial intelligence based method. And like I said, it's the most recent of any of the methods. Now, the next aspect we are going to be looking into is what we call the incident detection algorithm. There are basic three parameters that are used when evaluating the performance of incident detection algorithm in traffic management. Three key measures are commonly used. These three key methods that are used is what we call the detection rate, the false alarm rate, and the time to detect rate. So these three parameters are very important in measuring because, like we said in the earlier part of this lecture, that the reason why we add the introduction of this algorithm is to be able to know the detection time when an incident happens on the road. The quicker the detection of that incident, the faster the required agencies or the required emergency services are deployed to that location in order to clear up the incident on the road and restore traffic flow. Now, these three parameters in incident detection algorithms that we have already explained so far are quite important to measure its performance. For the first one, we have what we call the detection rate. Now, the detection rate, like I said, is what the proportion of actual incidents that are correctly identified by the algorithm. So the detection rate generally is considered the ratio of the number of detected incidents to the total number of incidents. What I am trying to say is for any algorithm that is being deployed, if the percentage of the number of the incident detected over the total number of actual incidents that occurs is what we call the detection rate. For example, if the total number of incidents that happens on the road is 50, but the algorithm or that particular based method was able to detect 30 out of the 50. So that means that that particular algorithm method is only able to detect 60% of the incidents that happens on the road. So the detection rate is you can only know the detection rate of any algorithm by calculating it based on the total number of incidents that is being detected by that method over the total actual incident that happens or event that happens on the road times 100. That will give us the detection rate. Any algorithm or base method is as important as having the higher the detection rate, the more efficient or effective that particular algorithm is. The lower the detection rate, that means the less effective that particular algorithm is. Because the reason for this being in place is to be able to have a high detection rate of whatever incident that happens on the road. So any algorithm that has a higher detection rate of incident on the road shows that that particular algorithm is quite effective and it helps us to measure the performance. Like we said, the detection rate is not the only important measure of performance because there are some algorithms that might have a very high detection rate and still have a high false alarm rate, which is the second point. The second point telling us about the false alarm rate is the proportion of non-incident conditions that are incorrectly identified as incident. There are some cases whereby, due to some of the abnormalities or due to the threshold that are used in those algorithms, it might pick a signal like as though there is an incident on the road, but in reality, there is no incident on that particular road. So that is what we call a false alarm. And the rate at which it happens is now what we calculate as the total number of false alarm cases over the total number of algorithm alarm decisions times 100. That will help us to understand the false alarm rate of any of the incident detection algorithm that is being used. A lower false alarm rate is desirable as it indicates that the algorithm is not overreacting to normal traffic conditions. But when there is high false alarm, this can lead to unnecessary responses and can undermine the credibility of the detection system. We can have some algorithms in which I'm still going to be showing a diagram of it later in this lecture. We can have an algorithm that has both high detection rate and also have high false alarm rate. We cannot say this algorithm is that effective because even when it has high detection rate, but in most cases also has been able to detect some incident that didn't actually occur and presenting them like as though it occurred, and that is what we call the false alarm rate. The last part of this is what we call the time to detect. For the time to detect is the amount of time taken by the algorithm to identify an incident from the moment it occurs until it is detected. Like from what we have in this slide, it says TTD, which is the time to detect, the time of the detection minus the time of incident. Let me explain. If the actual time an incident happened on the road is 4:30 p.m. and the algorithm is speaking or detecting that incident around 5 p.m., that means it has a longer time of detection, in which is not the case. But in sense of seconds or in terms of minutes, when the higher the detection rate, the less effective that particular algorithm is. Because the idea of having these technologies or these algorithms or these detections in place is to be able to speak or to be able to respond to any incident on the road as soon as it happens. And you can see here, algorithms will often adjust the persistence of the alarm. This persistence determines the number of time interval that the incident level flow disruptions must exist before an alarm is raised. Since most algorithms use 20 to 30 seconds time interval for this. Typically, it is measured in seconds and it reflects the responsiveness of the detection system. Now, a shorter time to detect is crucial for effective incident management, as it allows for quicker response time from traffic management centers and emergency services, ultimately reducing the impact of incidents on traffic flow and safety. Like I explained in the previous lecture, that if the detection rate is taking longer than usual, then that means the traffic flow that has been disrupted as a result of the traffic incident will keep building up, leading to traffic congestion and leading to traffic jam. So the time at which before the traffic flow is disrupted for long, causing a high number of vehicles being stopped on the road, and if a prompt detection is in place that has actually alerted the relevant authorities or the relevant traffic management centers, then the possible emergency services will be deployed to that location before there is any form of abnormality in traffic on that road. So these three measures of performance under incident detection algorithm are very important because they all work hand in hand. You can have an algorithm that has, like I said, high detection rate, but has a also high false alarm rate. Then we can say that particular algorithm might not really be as effective as we would want it to be. Compared to the best possible algorithm will be an algorithm or a measure of performance where it has high detection rate and a very low false alarm rate. Because there are sometimes that this is technology, so there are sometimes they might pick some things on the road thinking it's actually an accident or an incident, but it's actually not. It's quite understandable because it's not said to be perfect, but it must be to the barest minimum compared to having it in maybe a very high percent of maybe 40%, 50% of detection on the road. Now we're going to be looking at a table based on some of the research that has been done in the field using some of these algorithms by some past researchers. Here we have the detection incident algorithm measure of performance. Yes. So these are some of the algorithms. And here is DR, which is the detection rate in percentage, the false alarm rate in percentage, then the time to detect in minutes. This McMaster, all et al. 1993, we saw that the detection rate is within 68 to 88%, and the false alarm rate is less than 0.01. This false alarm rate is very good under this algorithm. But here we can see the time to detect is within 2.1 to 3.2 minutes, which is so much compared to some other ones we have here in this algorithm. Now, we have the ANN. We have ANN also done by Ritchie and Shio 1993 here. We have the PNN. So under the probabilistic neutral network here, which is the PFN, we have Abdul High and Ritchie 1999. Here, the detection rate is 98 to 100%, almost 100%. And the false alarm rate is within 0.0 to 0.5%, which is still very reasonable. And the detection time to detect in minutes is 0.3 to 2.5. Even when the range is up to the point of 2.5 minutes, but taking the positivity of high detection rate and almost less than one false alarm rate is quite a positive one in using this particular algorithm. You can see some other ones here like the California 8. I don't explain this under the first method, which is the comparative algorithm. So here we have the detection rate is 71%, and even when the false alarm rate is quite lower than that of the PNN. So these are some of the research that has been done over the years by some researchers in the field of traffic incident management, and whatever these decisions can be made based on this for any system or any traffic management system that wants to deploy any form of this algorithm can make use of some of this information to be able to decide which of this incident or this algorithm you're going to be making use of. Like I said, the every algorithm has its own deficiencies in one way or the other. Like you can see with PNN, detection rate is high, false alarm rate is quite low, but the time to detect is within 3 seconds and 0.3 to 2.5 minutes, which is still a bit on the high side. So decision on which algorithm to use at any point in on the road, it's now dependent on the traffic management system or whatever authorities that are in charge of of that or setting that up, because everyone looks at the advantages and the disadvantages of whatever system in place, and also and also another factor that is being taken into consideration is the condition of the road. Some might decide to go ahead with the PNN, maybe due to some factors they are taking into consideration in sense of maybe they don't that particular city or that particular road does not have any much problem with the time to detect. And time to detect is not really a problem, but they have much more focus on the detection rate and the false alarm rate, which is quite on the positive side with PNN. But there are some road conditions that might prefer to take the TCD as a very prior or the most important measure of performance. That is because the earlier detection of any of these incidents helps them to be able to respond as soon as they can. Just like we have some of them having 1.1, like the lows. The lows has about 1.1 times the detect rate. So each and every one of them have their own advantages, like I said, and also has their disadvantages. And it is based on this. And I know with time and over the course of the years, there will still be more algorithms that will be introduced in order to have a better detection rate, false alarm rate, and time to detect rate beyond the ones that have been highlighted in this video. So that is it under the incident detection algorithms. We've been able to look into the incident detection algorithms. We've been able to look at the four methods under incident detection algorithms, and also the measures of performance of this, talking about the detection rate, the false alarm rate, and the CTD. And here, from here, we can see summary of the result from the AID performance review in Australia, which was written by Luke et al. So, research done by Luke et al. In 2010. So thank you very much, and I will see you in the next video.